Hi! We are continuing 6.4. All right. And so, again, I want to remind you about some of our exponent rules, just so we have them. I know we talked about them yesterday, but they're going to be super important today. So, again, I want to remind you, if I have x to the m times by x to the n, the bases are the same. I can do what with my exponents? Add them, m plus n. If I have x to the m divided by x to the n, I keep my base, and what do I do with my exponents? So I have m minus n. If I have x to the m raised to the n, I multiply my exponents. And if I have a negative, so let's say I have x to the negative m. Correct. Goes down to the bottom, so it's 1 over x, and then my m becomes positive. He's happy where he's at. So while we're at the same thing, what if I had 1 over x to the negative m? It would go to the top, exactly. And it would become positive because he moved and now he's happy. Okay? All right, remembering all those rules, here we go. I'm so excited about today. So, here's the one rule of thumb. If, as simplifying, the problem starts as a radical, then change to a radical at the end. So that means the same thing as if it's a fractional exponent, it's got to be an exponential form at the end, right? However it starts, that's how it should finish. Okay? Again, this is all stuff that I said yesterday. All right, so we're going to start in the first section. We're going to continue where we left off yesterday. Okay? So we're going to start with example number 1. And this is in your first section, which is going to be 44 and 46. If I have the square root of 6 over the cube root of 36, can I reduce them? No. They don't have the same dimensions, right? So we're going to change them to fractional exponents. The top one is 6 to the power of 1 inside a square root. The bottom one, tell me about 36. That is 6 what? 36 is 6 squared, correct? This is the same as 6 to the second power? Yeah. Okay, so we can rewrite this as 6 to the power over root.
Okay, so what if you didn't know? Can you just write it as is, like with 36 or no?
Well, you're going to have to break it down in order to do anything else with it. Yes? Okay. All right, so now bases are the same, right? And if we're dividing, what do we do with our exponents? Subtract. Very good. So we're going to keep our base. It's the top exponent minus the bottom exponent. Now you can use your calculator if you want to go 1/2 minus 2/3, math center, enter, or we can get a common denominator. Common denominator is 6. What, Caden? 12. It is 6. So here, if I multiply the bottom by 3, I multiply the top by 3. If If I multiply the bottom by 2, I multiply the top by 2. So my fractional exponent is negative 1 over 6. Does everybody agree with that? So where does a negative exponent go? On the bottom. 1 over 6 to the positive 1/6. Okay, now I'm going to put it back in radical form. This is going to be 1 over 6 to the first inside a 6th root. Oh, you can't do that. You're right. What are we going to do? Yeah. So we're going to times it by the 6th root. How many more 6's do I need? So we're going to go 6 to the 5th power. Whatever I do to the bottom, that's right. So on the top, I have 1 times the 6th root of 6 to the 5th, or the 6th root of 6 to the 5th. What do I have left on the bottom? Just a 6, exactly. Yeah. All right, are we good so far? Let's try another one. We only just got started. This is some fun stuff. All right. That looks good. Okay, so obviously we can't reduce this fraction because it's a square root on top and a 4th root on the bottom, right? So the easiest thing to do is to make them fractional exponents. So this is going to become x to the 4 over 2, right, power over root, y to the power over root, over. On the bottom, I have x to the power over root, y to the power over root. See, that part wasn't so bad, right? Good? Okay, so now we're going to simplify some of those wonderful fractional exponents. X to the 4 over 2 is just x what? Squared, good. I have y to the 1/2, because that doesn't simplify. What about x to the 2 over 4? 1/2. 1 over 2. And here I have y to the what? Okay. Any questions so far? All right. So now, got to change them back into radical form. X to the 2nd is not a fractional exponent. So he is good. He stays just like that. Y to the 1/2 means I have y to the 1st power inside a square root. On the bottom, I have x to the 1/2. So that's x inside a square root. And then we have y squared. Does he have a fractional exponent? So he gets to go in front. Any questions so far? Okay. So what's the last thing we have to do, Ethan? What do you think? Rationalize. So this is a square root. I have to multiply by how many more x's? Just 1. Multiply by the square root of x down here. I times by the square root of x up here. So my final answer is going to be x squared, square root, xy, over xy squared. Now what do you notice? Whoops, my bad. What else do you notice?
Oh, you can simplify your x's.
We can reduce an x. This x cancels with this one. So we end up with x square root xy over y squared.
If we work so good, we should
You think so?
because we're just better than
Okay, keep listening and we'll see where this goes, okay? All right, here we go. We're good? Let's move to example number 3. Example number 3, in the next section, it simply asks you to simplify. And maybe they give you something as wonderful. You like how I said that was wonderful? As 64 to the 2/3 times 64 to the 2/3. Okay, what can we do with this? They do have the same base, so we can add our exponents, can't we? Okay, so that means I'm going to have 64 to the 2/3 plus 2/3, or 64 to the 4/3. Okay? No. Yeah, so now we're going to change this to radical form, right? Think about how we can simplify this. So we have 64 to the 4th power inside a cube root. Okay, hold on. So how many 64s do I have in there right now? There are 4, right? There are 4 64s. A group, yes, I'm getting there, Keating, yeah. A group of 64s can come out, right? So I can take a group of 64s out, which is going to leave me with just one 64 left, which is 4, exactly. So we're going to times this by 4, and we get a total of 200 and, thank you. I'm trying to multiply in my head. So in this section, which is problems 48 through 54, if you can simplify it to a whole number, by all means do that. So if you can throw it in your calculator and do it that way, do that. Like this would have worked. If you can't, then you got to do it the other way. But if you can simplify it in your calculator and it works, let's do one more like this. So for example, what if you had 10,000 to the 0.75? Yes. Do you want to check and see if it works in your calculator first, or shall we do it by hand? You should check the calculator first. It is 1,000. Okay, so again, in this section, if you can simplify it with your calculator, which I'm giving you a huge hint, do that. Okay? All right, we're on example 4 or 3? 4. Example 4. All right, the last section, 56 through 66. Let's try this one. Let's say I have x to the negative 4/7 raised to the 7th power. An exponent raised to an exponent, what do we do? Yep, so it's going to be x. If I multiply my exponent, negative 4/7 times 7 gives me negative 4. So now if I have a negative exponent, where's that going to move to? Yep, so it's just going to be 1 over x to the 4th. That's it. Example number 5. Let's do 5 times x to the 2/3 raised to the negative 1. An exponent raised to an exponent, what are we going to do? Multiply them. So I'm going to have 5x to the negative 2/3. What's that tell me I got to do with my wonderful x? Good. My 5, though, doesn't have an exponent on it, so he stays. So I have 5 over x to the negative, oops, sorry. When he moves, he becomes positive, doesn't he? Oops, sorry about that. Positive 2/3. So now how should I write that?
You gotta do the box inside. Don't you?
Put it into, so this is technically 5 over x squared inside a cube root. What do I have to multiply by?
1x.
The cube root of x. Whatever we do to the bottom, gotta do to the top. So on the top I get 5 cube root of x over x. Now, how did this problem start?
With 5 parentheses x to the 2 thirds.
Right, there was no radicals, it was fractional exponents, right? Okay, so that's how I'm going to finish it. This is 5x to the power over root over x. One more example. One more example. Let's do,
I like how you write your names.
how about if we do x squared over x to the negative 11 raised to the 1/3 power. Well, I have a negative exponent up there. What should I do with that?
Move it to the top.
Okay, so I'm going to move this to the top, which means I'm going to have x to how many on top? Oh, you're just adding, you're moving it to the top.
I have 9. Oh wait, 11 have 9.
If I move it to the top, that means it comes this.
13.
There we go, 13. All raised to the 1/3 power. An exponent raised to an exponent is? We multiply. 13 over 3. And this started as exponents, so we leave it as an exponent. Nothing else to do. Do you want me to say that again, Lexi? All right, so here's what I want to do.
Did you hear that?
Listen. Here's what I want to do, if everybody's still listening. I still have 3 more minutes of your time. 3 more minutes of your time. We're going to continue this because I didn't go quite through it. So, yes, you guys get a reprieve tonight. Okay? No homework. All right?